Hi guys, we're TIKOS and this is our final presentation. So hi everyone, I'm Nafisa and I was the project manager for TIKOS. To give you guys a brief overview of my role, it mainly consisted of creating the timeline and sort of managing it, making sure everyone knew what their allocated tasks were and they were completing them on the deadlines. Obviously being realistic, we had a few mishaps and it was just my job to work around them and make sure that we were still on time and we had our final thing done. And I was also in charge of collating everyone's work to produce a final standardized version of it, and I did like 2 drawings as well.
Hi, I'm Heather and I was on the Physics Research and Development team. I wanted to take part in the Industrial Cadets as it would give me valuable practical experience and team working skills which I could later use in uni.
Hi, I'm Zach. I was in the Physics Research and Development team, and when choosing to do the Industrial Cadets programme, I knew that it would give me hands-on engineering work, and I found that highly appealing, so I went to see it.
Hi, I'm Callum. I was in charge of the robot coding and graphic design to make the final CAD model that we've made. My aspirations for this were to get hands-on experience with engineering and to further develop my CAD and coding skills.
Hi guys, I'm Matthew and I took on the role of the engineering technician. I signed up to the Cadets programme with the hopes to gain an initial insight to the career of engineering, and also wanted to sort of get my foot into building positive relationships with other businesses like Thales.
Hi, I'm Jack. Throughout the Industrial Cadet programme, I've took on the role of the engineering technician. This has involved the coordination and construction of sketch and final models. What I'm looking to get out of this award is hands-on experience as well as a better understanding of the engineering and product design industry.
So as we embarked on our Industrial Cadets journey, we were presented by our aim and brief by our mentors at Thales. The brief stated that we were to devise a system to transport several military cameras across the floors in their Glasgow site. The brief consisted of specific requirements and preferences with the expectation to produce a solution that was both sustainable and long-term.
With these requirements, our team highlighted several potentially major obstacles that would need to be prioritised when producing our solution. One of these was the obligation that our method of transport would have to pass through a clean room, meaning that extensive measures must be taken to prevent dust coming into the room, with the possibility of contaminating the room itself. Bluetooth was also prohibited to eliminate the risk of hindering the performance of the testing facilities.
Using our research, problem-solving and critical thinking skills, our group have managed to produce a viable and high-quality solution that exceeds any initial hurdles in the form of our idea, TIKOS by Thales.
Before we go into a detailed view of our journey, I'd just like to give you guys a brief overview of it. So as we got given our EDT timelines and from Thales our brief, we decided to plan using the Gantt chart what our journey would look like, what we think we would have to do. And after doing that, we sort of split and just went out and did a lot of research to understand what existing solutions were, any materials about Thales. And doing that research, we came into group meetings and we sort of brainstormed any ideas we could think of, literally anything. And from that, we split up individually and decided to do some initial ideas, which were just annotated drawings of literally anything. We had stuff from drones to zip lines to boats, anything you could think of. And we presented these ideas to our mentors, and from their feedback and a self-credit of each other's ideas, we shortlisted and came to a final solution. And taking that solution, we sort of integrated other components we would like maglev, etc. And we refined that final idea, and between the refinement, there was some experimenting because maglev requires a bit of physics. And from that, we produced our final things, and we are currently on our last stage. For the planning and research, as I mentioned, we used a Gantt chart. As you can see, obviously that's not what the timeline did actually look like. It did switch about a bit, but that's an overview of what we used for it. And the research part, we used a feed stamp mind map, which was more of not a feed stamp because we didn't use all the letters, but we sort of went away, did some research for a lot of weeks, came back, and that's not all of our research, it's just the ones we could find. But we just took them and then collated them into A3 pages of research, which we then took forward to sort of brainstorm our ideas.
In the initial weeks of our project, our team carried out several meetings to gain an idea of what we wanted to put into our solution and develop any other talking points within our brief. Our meetings took place on regular Tuesdays, however sometimes we did go and meet each other out of school on weekends. These brainstorming sessions were very effective as a way to bring the team together and get ahead of our schedule.
We each presented our initial ideas. Shown on screen are just a few of them. When creating our initial ideas, we wanted to keep it as broad and creative as possible. No idea was a bad idea. We thought of some out-of-the-box solutions, like a boat which would go along a river, or we got a drone which would fly through the sky. However, they had their drawbacks. The river was impractical and potentially problematic when dealing with electricity, and with a drone, if it was to fall out of the sky, be a major safety concern. We then looked at a hamster ball idea, which ended up what we based our development sketches off of.
So our next couple sketches here were an idea of having a rail system that would be attached to the factory roof, and it would be, its purpose would be to avoid any obstacles on the ground, people or any workstations. Another idea we had was kind of the same thing, but instead of it being attached to the ceiling, it would be put into the ground. We didn't go with this in the end due to some safety reasons of it could derail if something got stuck in it, and it could damage the product or hurt people. Below that, we have a sketch of one of our first ideas was to have a kind of track system, like a tank, so that would allow it to make tight turns and go into smaller spaces, so it's out of the way of people. And the other idea was to have this main idea was to have put on top of something, but it would be two rails that would kind of enclose the thing to stop it moving. Then one of our other ideas was to have a maglev kind of train that would go along the factory. We've taken this forward, but not in the sense shown in the drawings. We have put this inside our robot to kind of stabilise it going over bumps and stuff.
Throughout the shortlisting and development process, there were a fair few ideas that we wanted to review and test, one of these being the idea of incorporating maglev technology into our final product. After some thought, we ended up being various ways in which this could be integrated to our model. One of these being the suspension and support of the product itself being upheld by the precise placement of magnets within the interior of the contained chamber. This is where the product would be stored during transport. After gaining as much information as we could about the company's needs and preferences, we started sketching what our final model would look like. As we sketched and thought out our model, we found alterations that would be required to reach a refined product. Therefore, we kept on developing the product as shown below.
So I was in charge of making the LEGO EV3 robot follow coloured lines and move around that way. So we have the code at the side that demonstrates what we wanted it to do and how it would do it. So at the start it would send a light down from the sensor onto the ground, and then that would reflect back up to detect what colour it was. And if it detected, the colour here was black, we wanted it, a black line we wanted it to detect. And if it detected that, it would send a signal to the wheels to move 50% and 0%, and then that would switch over, so it would kind of move in a zigzag pattern across the ground. And if it didn't detect any light that it was wanting, it would spin in a circle until it detected something. I would like to now show you a quick example of how that works. Sorry, it switched off. While it's going on, we did have some problems with the robot as the light didn't pick up properly due to different lighting in different places. The solution for this was we would have to calibrate every time we moved it about, but that didn't always work as it kept on glitching out still. So this could be used to other problems with it, and I've tried to fix this for this model. As you can see, it does start to detect shadows. That is to do with the lighting. And that is probably one of the main problems we have with it right now. But we should have that fixed by the time we finally use it.
Right, so to begin with, we started to understand the physics behind magnetic levitation. Magnetic fields are created by moving electric charges, and the magnetic force is perpendicular to the current, so the force will act upwards through the coils. It's shown in that diagram up at the top left, to give a sort of basic overview of what it's supposed to be.
We found through experimentation that different coils induce different magnetic fields using different currents. Whilst theoretically, the more coils, the greater the magnetic induction is, as you begin to add more coils, the resistance increases, so then you need more current to reach the same. So we found that 2,400 turn coil provided us with the best ratio of magnetic induction to current. With our lab packs, we were limited to the amount of current we could get up to, so with better equipment, our results could definitely be scaled up.
We wanted to prove that our idea worked, so we used one coil and one magnet to feel a lift. We added a stabilising ruler contraption, which I'll show you in a minute. That prevented the magnet from flipping and was able to show the lift clearly.
The difficulty with using this ruler contraption is it was unstable holding, and the sellotape did get in the way with a lot of friction and uneven sides.
We then created a longer, more durable contraption using several rulers, which is that one, and that had magnets taped below it. This allowed us to place a load on top and determine how strong the magnetic fields were that we induced. This eliminated the limitation of one magnet, but it wasn't durable and it wasn't stable enough to actually keep the magnets afloat without falling over and falling off of the actual contraption.
We needed to think of a way that could eliminate many issues, and so we considered making a jig with several materials, such as wood, cardboard and copperboard. Our final decision came to acrylic due to its low friction and speed in production using a laser printer.
We used 2D CAD software to design a shape to be cut out using the laser printer, and this would be assembled to make our final encasing for our experiment. This provided us with the stability and rigidity to withstand an approximate 2.2 kilo gross weight and a 1 kilo net weight. That's a bit of a demonstration of how it's working.
The restriction of our equipment prevented us from attempting more, with a maximum current output at 1.9 peak at room temperature. With installation of a cooling system, we could reach higher currents and therefore achieve higher lift. This could be done with fans or with radiators and a liquid cooling system to maximise thermal transfer.
In order for our final model to be constructed as structurally sound as possible, there were some calculations that went into ensuring our measurements were correct and precise. We thought out the required measurements and reached some conclusions by incorporating anthropometric data, while keeping in mind aesthetics and practicality. Following these measurements, we drew up a refined and detailed sketch for our final vision. In the interest of being environmentally friendly, we advised using solar energy in order for this robot to operate. On this sketch sheet, if you can come back, you can see the different categories that we split up and all the considerations that we took. Some of these different components, the lid, levitating box, the actual maglev box itself, as well as the base that everything would be stored on top of. The role of engineering technicians was a challenging task, with the end goal being to produce a practical 3D model. Our model had to be as close to the final solution as possible, while still fitting within the boundaries of being a sketch model. After brainstorming a couple of ideas, we decided to produce a 3D printed connecting bracket that would attach to a storage unit onto the LEGO EB3. To create our connecting bracket for the model, we utilised our existing skills and inventor professional to design and develop our sketches.
With our parts created online, we were able to utilise a 3D printing machine to create a physical model using PLA polymer. We decided to use a blue colour for the base to coincide with the colour scheme of Thales. Creating our initial model was not a smooth process though. A key difficulty that we faced was during our 3D printing when our parts were curling up from a lack of support. Luckily we managed to overcome our problem by using our initiatives and providing a wee bit more structure when printing. With the base and connecting bracket finished, we created a box that would hold the camera and attach to the 3D printed base. The box is made of cardboard and has been hollowed out at the bottom to allow access to the robot's face. After an initial model was created, we spoke to our mentors at Thales to gain some feedback and make some accordant changes. After our meet, we met together as a team to discuss the next steps that needed to be taken to ensure our success. Our final draft had some newer changes whilst the core idea was still in place. And a new process that we learned about was laser cutting, which we use when creating our outer shell for the model.
With our parts cut and ready, we used our hot glue gun and a lot of care to manufacture our final physical solution. Our Talic features a white body covered in Thales branding. The Kappa board box has been covered in a sheet of plastic, and an acrylic dome is placed on top to access the storage unit. Overall, our model has come out very successful, fitting with our provided criteria.
So our next stage was to create a 3D CAD model of the sketches that we had. So this was our original one that we had come up with that we showed when we went to Thales last time. Just quickly get this. So as you can see, this one was quite similar to what we have come up with, but we've changed what robot we were using underneath, as this one was quite wide and it was hard to move about. Sadly, we couldn't find the robot we wanted to use on GrabCAD, so we weren't able to put it in this. But as you can see on the bottom here, this would be where it basically would slide in and kind of attach to the sides. So this is our final model here. So we had a lid at the top that would be opened using the handle that is also attached at the side with like a hinge here. It's not really easy to see that. Also, we had a rubber seal that we'd set in between the lid and the main base, the cylinder, and that would create a kind of an airtight seal, not allowing for like dust and any particles to get in to contaminate the thing before it went into the clean room. We also had an impact base at the bottom here, so there was the effect of if the thing was to get hit by anything, by someone either walking or someone dropping something onto it, that would kind of absorb most of the impact and allow it to kind of not break anything inside or damage any of the maglev equipment, as you can see here. And that was, the maglev is, again, talking about it to stop it like moving about too much as it goes over any bumps.
With our journey coming to a close, we can all look back and reflect on the time that we spent in the Industrial Cadets. Not only has it been great to work practically on a real-life engineering problem that we may face after education, but it's also been great to develop great friendships and that we will remember fondly. It's been a great experience getting to work with such a great company in Thales, and we hope that our solution is an innovative way to fix your problem.
Right, thank you. Also, we'd just like to go back so you guys can demonstrate the physics experiment.
Right, I think we should plan it so we can kind of see it floating. Ja, das geht nicht. Yeah, just you can, don't know if you can see.
Feel free to come around and you can feel the resistance as well.
I think it's caught on something there.
Yeah, that's it.
Like caught on the side. But it takes a fair amount of weight, like that's 100 grams, and it's not really made a difference. I think we managed to get it up to 1 kg, but that was when we had it with like it was quite cold, so the amps were high enough to do it. I don't know if it'll do it today, but
Yeah, it gets hot quite quickly, so when it heats up, the current just drops.
But like that's like 300 grams and it's not really moved. So if you were to scale it up, like these are obviously demonstration coils, so in like the actual model, they'd be much smaller. Like they wouldn't be so bulky, and it would, yeah.
Feel free to come around while it's running, you can feel it bouncing and stuff as well.
Yeah, it seems to be caught on something, I don't know what's happened there.
The coils pushed down a wee bit, is that pushed down?
I don't know if that.
It might be when the plastic, when the acrylic sheet came off.
Yeah, it might be. But yeah. Anyway, it's a lot. I think last time we showed you it was that weird, like that little ruler thing, so it came on a long way since then. Yeah, should we turn it off?
Yeah, we missed this one.
Oh yeah, it was a bit, it worked, it was just really bendy, so when we put the weights on it, it couldn't hold as much as that one could, just because the rulers were bending too much. So we decided to upgrade it.
That was a really amazing presentation, everyone. It really was. It was. I've not been involved with this except really since the very start. I think I was on one call, but it's amazing to see where how far this has come from just an idea actually that James and I had. There is a problem in Thales. How can we get it fixed? And actually, I never imagined it would be something as good as that. So I'm really impressed.
I was taking notes at the very beginning, and I stopped because I was too focused on actually seeing what you guys were doing. So I have very few notes now. Yeah, it was really, really impressive, and it's also really cool because when I was doing this at school, I couldn't get it to work, and this is leaps and bounds beyond anything that I was able to achieve. So really, guys, you should be really proud of yourself. So.
Thank you.
Thank you so much. I liked how you all worked as a team as well. Yes. That's come through a lot. And you said you worked even at weekends and stuff, so it's amazing. It's absolutely amazing. It really is. You should be so proud of yourselves.
Okay, thank you so much. If you guys have any questions for any of the slides, solution, feel free.
On your Gantt chart with so you were displaying, did you have any dates that you'd initially put for it, or was it specifically phase based? Not sure if I spotted any.
So any dates for the deadline?
Yeah, so did you dedicate certain time between those phases? So you had all of the points, but did you have any ideas of did you have any predictions on how long those periods would take you, how long that was going to split?
So for the thing, we actually just split the main tasks we would think, like research, brainstorm, initial ideas. So we split them and then we split those into subtasks, and we didn't have dates of the final deadlines, but as I said, we sort of plan using the EDT deadlines, so this is like a sort of mimicry of what the EDT deadlines were, but obviously within a buffer zone. That switched about, but we still got the main flesh of most of our work done before the deadlines.
Right, yeah.
So that's not the EDT one, that's in weeks actually, that's the timeline is in weeks. But sort of our deadlines using the EDT ones.
Okay. Yeah, because that's always the challenge when work always takes longer than we expect, and that's sort of like preparing in advance. So it's really good that you guys have buffer zones as well in case you overrun.
Any other questions?
See, when you were going from initial ideas, development, refinement, how did you decide on what idea to take forward? Like, did you do any analysis techniques on it to the benefits and the cons to it in each one, or did you just pick one?
We listened to the feedback. The idea we picked forward ended up being not really that close at all to our final idea. Mm-hmm. So it's more we liked the encasing idea of it, and we combined it with a couple of the other ideas we had, like the maglev and the sketch model, and just like a basic kind of the robot thing. And we just combined a few to give us the final one, so it's more just the bits we liked of all of them, and listening to the feedback we got given from Thales when we did present all the initial ideas.
This is not really a technical question, but what did you call it? Did you call it a Dalek?
Yep. Yeah. Not
Is
sure
it Dalek and Thales sort of merged together?
Don't know if we've got any Doctor Who fans, but we've actually got the
nice.
Dalek.
Oh, good.
Matthew, I don't know if you want to bring the EV3 over, and if you guys want to have a closer look as to how this would actually slot on.
Can I have our own little Daleks running inside?
Yeah, exactly. So the dome here, it sort of detaches so you can access the face The sort of 3D printed part here has been stuck on by double-sided tape, and it'll fit on. I think this is it. It's pretty much. So it'll have a wee bit of it'll have a wee bit of space for the wheels and stuff to move, and it'll also allow it to detect the light underneath. Yep. So we can put our things in it, and it will. We can still access the actual face to help program it and move.
And how does the maglev then fit into this specific product here? Would it be replacing the wheels eventually with a maglev system, or is it actually the product itself?
I think it's to hold the product, if I'm not wrong.
Yeah, the product, there would be like a maglev chamber. It's like, that's a sketch model, the CAD model is the better representation of the design, but you do have like a maglev chamber inside the encasing, and that would sit on a pre-made robot that you can buy off like RoboSav or I think just like robots out there, which would be the base with the wheels, with the built-in sensor and all of that.
Yeah, the experiment's just to show the concept of the maglev actually working, but that would have maglev on the bottom and the sides to completely isolate and not keep it from touching any of the walls.
I don't know if you guys can see the thing. It's just essentially, it's like a plan of our electromagnet box. So the electromagnets are at the bottom, and that's essentially going to be that. And this is the component over here, and these magnets are just to stabilize the actual product. And this robot actually gets, as Cam said, this is just a cross section of the whole thing, and this is what the CAD model was based on. So the HLX tracer gets slotted in here, and then the maglev box goes on top, and then our sort of final goggle things that's carrying the goggles floats on top. Not that much, that's just for showing the other things, but that's essentially what the idea was.
Fantastic.
I think if you could add like a exploded view on the CAD model and say really basically this is what this is doing, that would make it a lot more clear.
Yeah, that was our next one.
Yeah, that was the next thing.
You've got that in the report, haven't you, Callum?
I think
Exploded view in the
Yeah, I think
report.
he's working on that right now. Yeah.
Just to make it more clear, because I wasn't really too sure until at the end you explained what the maglev was actually doing, because I wasn't really too sure if it was the tracks on the road or the floor, or it was holding it. So I feel like if you defined that at the start and said more clearly, like this is what we did, this is why we did it, that would be
Thank you.
Yep.
Thoughts?
Thank you very much. Thank you.
Right, thank you so much for taking time out.
That was great.
No, thank you very much.
so much.
It's a great way to spend the afternoon.
I don't think anyone else will have this idea, so it's a good idea.
Right, now the technical bit's over, I'll throw the good teacher question out. If you were to change something, this is the first time you've done this as a team, if you were to change something in the whole process going forward, I'm going to come to every single one of you, what would you change about your performance? See, told you I'd be awkward.
I like the question.
What, our performance individually or as a team?
Your performance individually as part of the team, how would you change the dynamic? What would you do differently?
Yeah, I can start off. I think at the beginning, I think identifying, being more confident with what we thought and knew our initial strengths were coming into the project, so we more quickly would have been able to break off into groups and sort of divvy out the work that was going to have to be done, and maybe we would have been able to make slightly more development, even more technology incorporated into the final model.
Did you feel you know each other's personalities better than each other?
I'd say so.
I'd probably say time management at the start. It wasn't the worst, but it could have been a wee bit better. It did make it a wee bit more difficult to sort of get everyone on the same page. I think there was a wee bit of sort of back and forth trying to get to know where everyone's heads were. But sort of as we picked on and we sort of realised how it's sort of we've all come together and it's all worked out.
Do you feel that you're now picking up on moving into the world of work, the importance of things that we've tried to instill in school, like tried to obviously get to do, meet deadlines and work faster, but
getting ahead of the game at the start is is very clear. I would have said before that I'd sort of wait until the last minute to get everything done, but now I think it's much easier to sort of get ahead and it's all smooth sailing at the end.
I think personally I tend to be quite critically thinking, and I see like flaws in a lot of things. So I think when maglev was first introduced right at the beginning, I did think, oh, that's not going to work, I don't like that idea. But I think just being more open-minded, because it's turned out pretty good.
That's good.
I think I had the same thing when, like, if it was like Industrial Cadets Bronze or something. I think the kids were like still growing, still making up personalities. I think it was harder for the gold kids to sort of come together and understand each other, because our personalities are sort of getting more and more solid. So I think maybe just having more like team bonding exercises and understanding the personality, so the roles could be just perfectly to the person, because they're more likely to actually get work done to a good level.
So it's the first time for Woodfarm going through this. Is it something we should repeat?
100%.
It's a brilliant experience.
Definitely.
I think mine's kind of the same as Matthew's. It's
I was a bit confused there.
Mine's kind of the same as Matthew's. I do always leave my work until kind of like the last minute, but I think this is really kind of giving me an insight into like I need to kind of do my work when I like get it and just kind of put effort into it, or it kind of falls behind and doesn't really work too well.
My thing's probably that it sort of joins together with the teamwork, and it's that a lot of us, well, all of us really, tend to be a wee bit stubborn. So when we've got an idea, we want to run with it.
Yep.
But it'd be nipped on the bud very quickly. So then once we'd gotten over that, you could tell the difference before and after we stopped. Then you could tell that it worked a lot better.
Yeah, that's called the ugly baby syndrome. It doesn't stop when you go to work. It's when you become you love your baby in front of you. Everybody else tells you it's ugly, but you love it. It's the disconnect that you have between your work, and it's taking your personality away from your work, because it's a personal. When someone says this work they don't like, it's not a personal attack on you. It's an attack on the work. So it's always important to take that away. And you meet characters even at work to this day who will sometimes be a bit too blunt. And it feels like it's being offensive or critical, but it's a case that in reality it's against the work. It's not, taking your personality out of it, it's a challenge. And also, this is the reality of your working situation. You're going to be in group projects most of the time. Once you're in the work environment, it's no longer really doing independent work.
I was going to say that as well, Josh.
This will be the reality, exactly.
I think that working with like such a big company like TALS, and obviously the sort of severity of the project, like in the Gold Cadets is quite a big thing. I think it's all sort of made us sort of step up and realise that we're not all on our own. And I would say that we've all come a long way. We're now a great team.
You definitely feel a lot more happy to receive criticism when you're working. At the start, you're not really used to. Not really used to critics, but then basically the whole time, everything that you do was basically a crit in the end. But you're accepting it, and you know you're not perfect, so you're welcome to more criticism.
I think it's different coming from like focusing on exams and just being like, this is important, but reality this is more important because this is like a real life working situation. Like, you're never just going to be studying exam in a real life situation. You're talking to people all day, you're like brainstorming creative ideas, so this is more important.
That's one of the most attractive things about this whole project, was that it like mimics your outer life, or the life that's coming.
It does. It's the collaboration environment, because in fundamentally exams and things become competitive because it's set a certain ratio of people are going to pass, but that ratio is fixed every year, so only a certain number of people are going to get the highest grades. So fundamentally it's competitive, but this is the collaboration environment when you realise you need to work together to get something. Because it's very easy for teams of like a team of 6 to divide off into a team of 3 and just want to do their own thing, because there's 2 divided ideas, and that's defeats the point, because at the end of the day we don't want 2 products, we want 1 product, and that's what you've given us at the end of the day. So you've all been unified on your approach at the end of the day, even when you have disagreements, but you resolve them, which is really, really good. and also shows a good element of character between all of you to have all gone through a unified process.
And I think you all handled that scoring question really well. And I don't know if you would have done that as well at the start of this year.
It's a tough one.
That's the benefit of doing this. I've done my run of the graduation event, but with that in mind, you've got 2 weeks to go. What would you change about this presentation for the final? Do you think you missed anything?
I think making our ideas a lot clearer towards the beginning, because we sort of went through it and it was sort of like telling us what our ideas were, but they weren't telling you why and what they were meaning, like, to be used for. So I think establishing that at the start.
We did an awful lot of research and we looked up a lot of things, and I think showing where they have fit into our final design and just mentioning more of the key stuff, I think that's something.
I think linking all our components together as well, like explaining, as you said, like you didn't understand where the maglev thing was, maybe explaining this is the physics theory behind it and this fits in on the refinement page there, and then showing the CAD model exploded version. So probably just explaining the actual final thing.
I think having looked at your report that's gone off to EDT, there's a lot more imagery in there that would have made the presentation a bit glossier. But there's also a lot of images that you took showing the journey itself and how that bonding as a team has been visualised. The visit to Thales, when you presented in front of Josh and James, really good visuals there. That should be in the presentation as well, and also don't lose sight of the specification at the beginning. We kept referring to the thing. The payload. The payload was the thermal imaging goggles, and that was missing from the entirety of this presentation. But you'll be able to slot that in quite easily for the graduation.
Have you got like a photo of it, or
Photo of
Sophie, like the camera that you're actually transferring?
Don't think so.
Thermal imaging
Yeah.
goggles.
No, I don't think so. Got a sketch of it.
Yeah, I put that in and say this is the problem, we need to move this to here, and this is what we're going to work
I think
with.
we had rough dimensions of it as well.
Yeah.
You have photos sent over of the goggles, would that be okay?
Yeah.
James wasn't too sure.
Yeah,
last
I
time.
think it should be fine.
Yeah, it's all in the public domain.
Yeah.
You have
So
a
I think-
camera at the moment.
Uh,
There's official ones, and I'll get them sent. I'll send them over.